There are some more advanced things you can do with the formulas from the other lesson about the sum of the roots and the sum of the roots taken two at a time. So here's a quadratic that has two roots, and they're not easy. They're irrational numbers. A question that I can answer is, what is the sum of the reciprocals of the roots? Now, the rules from yesterday were for the sum of the roots, or the sum of the roots taken two at a time, or if it's a cubic, sum of the roots taken three at a time, and so on. This was not one of the rules from yesterday. But we still don't need to find the individual roots to answer this question, because if we get common denominators, this happens. And in the last lesson, we saw that the sum of the roots is negative b over a, which is 8 over 1. And the product of the roots is c over a, which is 14. I could reduce it if I want. But that's the answer. That is the sum of the reciprocals of the roots. I got that without finding any of the roots on their own. With a cubic, I'll call the roots p, q, and r. The sum of the reciprocals of the roots, it's not the same, not exactly the same, but when I do common denominators, I do get p, q, r on the bottom, but the numerators become qr plus pr plus pq. This numerator is the sum of the roots taken two at a time, and that's going to be negative 5. You don't change the sign because it's an even number. The denominator is the sum of the roots taken three at a time, or the product of the roots. It's going to be negative 7, not positive 7. If odd number of things at a time, we change the sign, and the answer is 5 over 7. Another thing we can get using the rules from the other lesson, here I have a quadratic equation. It has two roots called p and q, and I want to know the sum of the squares of the roots. And the trick is, we take p plus q and square it, we get p squared plus 2pq plus q squared. And then we could rearrange this if I subtract this 2pq from both sides. Oops. If I subtract the 2pq from both sides, I get on the right p squared plus q squared, which is my goal. And on the left, I have p plus q squared minus 2pq. Well, p plus q is 8, and I have 8 squared. And pq is 14, so I have 8 squared minus 2 times 14, which is 64, minus 28, which is 36. And that's the answer for the sum of the squares of the roots. An even harder question is the sum of the squares of the roots of a cubic, because for that, you'd have to say p plus q plus r. That I know. But when I square that, it's pretty complicated what it becomes. Go like this. It's going to be 9 terms. So p squared is going to be one of them. pq is going to be one, but there's also going to be a qp, so plus 2 pq. There's also going to be a pr and an rp, so 2 rp. This is going to be a q squared and a qr and an rq. And finally, the 9th one is r squared. So I would get p plus q plus r squared is equal to p squared plus q squared plus r squared plus 2 times pq plus pr plus qr. And if I move this over to the other side, I get p plus q plus r squared minus 2 times pq plus PR plus QR is equal to P squared plus Q squared plus R squared. Well, P plus Q plus R is going to be negative 2 over 1. And PQ plus PR plus QR is going to be negative 5 over 1. That's going to equal P squared plus Q squared plus R squared. So I get negative 2 squared, plus 10, which is 14. And as an add-in challenge, finding the sum of the cubes of the roots is actually really difficult. A hint is to compare and see if you see any relationship between them, and then an even bigger challenge to compare this to that. These things are sometimes known as Newton sums, the relationship between things like the sum of the cubes of 3 numbers versus the cube of the sum of the 3 numbers, and it's an interesting part of math, but that's the end of this lesson.